Here the question is, why fluorine shows anomalous behavior as compared to other halogens? Fluorine exhibits several anomalous properties compared to other halogens due to its unique atomic and molecular characteristics. And these anomalous properties include the high reactivity, weak fluorine-fluorine bond energy, high electronegativity and electron affinity, and the last one we can say the absence of d orbitals. More properties are there, including the formation of unique compounds, unique physical state and properties. Now let's come to the reason. The important one is the small size and high electronegativity of fluorine. Fluorine is the smallest and most electronegative element in the periodic table, and its small atomic size leads to a high electron density, which results in a very strong attraction for the electrons, and this high electronegativity gives fluorine a unique ability to form very strong bonds with other elements. It includes hydrogen bonding also. And the next one is the formation of weak fluorine-fluorine bond. Although fluorine forms very strong bonds with other elements, and the fluorine-fluorine bond in the diatomic fluorine molecule is relatively weak compared to the bonds in other halogen molecules. This is due to the repulsion between the non-bonding electron pairs on the two small fluorine atoms, which are closely packed together. The weak fluorine-fluorine bond makes the fluorine more reactive and allows it to form the compounds more easily than other halogens.